Hello everyone, I'm Marcus Hobbs. I am a product engineer. I create audio plugins. I'm the creator of Wilsonic, which is an interactive microtonal scale design tool. My thing is I go through academic papers and implement them so that you can tune up those scale designs in your DAW and tune up all the software synthesizers in your DAW. This here is Wilsonic. And this here is, just some examples of some of the designs that I'm implementing. The reason why we're here today is I'm evaluating AI tools to help software developers like myself to accelerate development. And I'm evaluating a tool called Cursor. Cursor is a fork of Visual Studio Code, and it is tightly integrated with ChatGPT 3.5 and 4. There's a partnership with them and OpenAI. And so this is an example of an integrated development environment deeply connected with artificial intelligence. And what I'm about to show you, we're going to do this live. I've already done this on some previous examples and seen some pretty mind-blowing results. So I'm going to go out on a limb and show you, we're going to do this next design together for the first time and see what happens. But so let me just give you some context. So I have a visual arts design background, and I really care about pixel perfect details in drawing. So this is Wilsonic, for example, and again, it's very detailed. So if you look, I'm really into vector line drawings. I care very much about the ordering, back to front. And the way I do this is I for every line that you see in a design like this, I stroke it with a thick black line and then the thin line of the color that you see. And what happens is that gives you a break, a line break here, and you see that here, and you see that here, etc. I also do it around points and stuff, and this gives you a sense of depth, right? So these are actually really large multi-dimensional structures that have been projected down to a 2D surface, so that one could play them as if you're on a keyboard. And so this particular design is a design called Hexadic. And again, this ordering, this back to front of these higher dimensional structures projected down into 2D, that's my thing. That's what I do. So I've already implemented a whole bunch of these. So for example, this is called a Tetradic Diamond. I actually have the original design here. And if you notice, this original design just has line drawings. This is created by Erv Wilson, this, the year before I was born. And there actually isn't really a notion of what line is on top of another line. These are just line drawings. They're all just on top of each other. There's no real line breaks. I think for Erv Wilson, it wasn't really super important what was in the back and what was in the front, because these are sort of isometric designs, and depending on how you look at it, you can kind of, it's an optical illusion. You can kind of flip back to front. But I personally like to interpret these drawings my own personal way. And so you can see in this drawing, I've done some things that Erv didn't really do in the original design. So, for example, I have this triangle here is actually a tetrad. It's a four-sided cube. And its opposite is actually in the back here. And so I've made that one in the far, far back. And so you can see every single one of its line segments has been broken up by the lines that are in front of it. This triangle here being the most front object. And so none of its lines are being broken because it's in front. So what I'm going to show you is just how this AI tool, Cursor and ChatGPT-4, is actually incredibly accelerating this very tedious, laborious process, for me as a designer to decide how to order lines front to back. So I created this design the old-fashioned way, just brute force. And so what I've been doing, I gave a talk on the Audio Programmer channel, is I've been using AI to help me create these other designs. So this is a Triadic Diamond. The Tetradic Diamond is the one we were just talking about. So Triadic means 3, Tetradic means 4. So this is created by 4 numbers, and so on. Pentadic Diamonds, the next leap in complexity, that's 5. And then 6 is the Hexadic Diamond, so this is where you take 6 numbers. And then Heptadic Diamond, 7. What I'm going to so I've already done all those, and I've used these tools for those, and I've actually saved the biggest one for last. So this is the Ogdoadic Diamond, so 8. So there's 8 numbers, 1, 3, 5, 7, 9, 11, 13, 15. And what I'm going to do right now, live, first time, is use these tools to create the drawing code for this. Now, if I were to do this without these tools, I could just tell you right now, this would take me a couple days. It's just incredibly tedious. It's just really hard. But when I've used these tools on the other designs, they were very predictive, and they would actually guess what line drawing I wanted to draw next, as if the AI was intuiting the back to front sort of ordering of all these lines. And that blew my mind, and that's why I'm recording this demo, just to prove to you, I'm not going crazy. This is actually what I saw. So, I'm going to put Wilsonic out of the way. So I'm going to go to Photoshop here. So Photoshop is the same drawing as what you're seeing over here. It's just I'm going to hop back and forth between this drawing here and the code. And the code, I'm going to insert all the drawing code here. And just to give you an example of something I've already done, what will that look like? So it's going to be a lot of these lines of code. So for example, let's say line, this is the 7, the heptadic one. So in my mind, I like to conceive of like layers, because I have a Disney background, so I really like compositing scenes in layers. Like that's the background, that's like the midground, these are the characters, this is the foreground, like kind of logical groups of layers. And so for the 7, I decided I'd have a rear necklace, like groups of 4 lines. Then I have another rear necklace that went to the origin. Then I have a front necklace, etc. So I have these logical groups in my mind. And keep in mind, this is just my own concept. I haven't coded that anywhere. I haven't described that anywhere. Erv Wilson didn't do that. These are just ideas in my mind that are not in the digital world. And my goal is to put them in the digital world. And so what I'm about to show you is how good the AI is at guessing what I'm thinking and what my goals are without me telling it in advance. So, okay, so this is the 7, and this AI helped me do this code here, this whole block. These are blocks of lines from front to back. So this is the backmost line, and this is the topmost line. And you can see there's dozens of lines. And I actually did that this morning before I even had my coffee in 15 minutes because of this tool. If it wasn't for this tool, it would have taken me easily, I don't even know, 8 hours. It's incredibly laborious. Okay, so let's go back to the Ogdoadic Diamond. And our goal is to fill out, flesh out this code. And so my logical ideas here are, it's going to be kind of hard to get to follow my mouse. So I'm going to pretend that the square here, this rectangle, is in the back. It's the backmost. And I'm going to pretend that, and they're labeled. So this is 311, 313, 1513, 1511, and then back to 311. That would be 4 lines that complete this square. Then I'm going to move on and do this one, 513, 515, 315, 313, and so on. And I'm going to do that for this one, and this one, and this one, and this one, and this one. That's a total of 8. So these are the backmost lines. And so let's see how good it does in real time. This is my first time doing this object. And see how good it does at guessing. And so the first maybe couple lines I'm going to type, and it'll probably have some bad guesses. But what I found on all those other designs was that very quickly it caught on to what I was trying to do. I don't know how. I didn't tell it. And I don't see a structure or a pattern here other than my internal conceptual sort of model. So I don't know how it's doing it. And I'm just blown away, and that's why I'm recording this demo. Okay, so let's get into it. So the first thing we're going to do is, like I said, I'm going to start with this 311, 313, 1513, 1511, and then 311. So let's see how good it does. So the way this tool works is when you're done with a line of code, so I started with 311 and 313, like the 311 to the 313. When you hit return, the next line, it actually will suggest to you, it predicts what you want to type next. And so let's look at what it predicted. It said it thinks that I want to do 313 to 315. Close, not quite. So I'll hit tab to accept it, but then I'm going to go correct this. So from 313, I actually want it to go to the 1513. So I entered a first point and no other information. It made a prediction. It got one of the 2 points right and the other one wrong. I've corrected it. So let's see how it does on the next one. And again, what we want is, I've said draw this line, draw this line. What I'm expecting now is, can it predict that I want to go from 1513 to 1511? So let's see how it does. And holy shit, sorry for my French, it predicted that I wanted to go from the 1513 to the 1511. That's amazing. So I can just accept that and move on. What's its next prediction? 1511 to 311. And sure enough, that was the rectangle that I wanted to draw. I told you all that. Again, there's no rehearsals going on here. I like to add a comment here, like that was my line, my rectangle number 0, and I've got, I'm a total of 8 till I'm done with this rear necklace. Okay, so let's keep going. So I hit return, and it thinks that I want to start with 311 and 39, and that's wrong. But that's not a real surprise to me, right? I haven't really established a pattern yet. So I'm going to correct it. What I really wanted is the 513 to the 515, so I could start this next rectangle. So I'm going to accept that, then I'll correct it. So I'll say 513, and then I'll do 515. And that's wrong there. And then I'll hit return and see what it thinks I want to do next. Now what I want to do next is I want to go 515 to 315. So what did it say? It said 515 to 1315. Now it made this mistake the first time. It didn't get that first guess right, but I'll correct it, right? So we want, 513 to 515, and we want 515 to 315. Now the next thing I want it to say is 315 to 313. So let's see if it can predict that. And holy crap, it figured that out. That's pretty amazing. All right, let's see if it gets the next one right. 313 to 513. Sure enough, it completed that square. So I gave it 2 hints, and it figured out the next 2 things. That's freaking amazing. Let's accept that and move on to the next thing. Now look at what it did. First of all, it knows that I'm doing things in groups of 4, so it suggested a block number 2 here, which is, oops, rats, I messed it up. See if it does it again. Okay. Now, the next block, we want to do 715. So it got that one wrong. So I'll accept it, and I'll say 715. And then for this next one, we want to go here, 7-3. So I'll say 7-3. Okay. So again, this is block number 0. This is block number 1. We're on block number 2. I set the tone here for 715 to 7-3. What I'm hoping it'll do is say 7-3 to 5-3. So let's see what happens. 7-3 to 5-3. Holy shit. Again, it figured it out. I gave it 2 hints, and it figured out the next thing. Let's see what happens next. Again, I want 5-3 to 5-15, and sure enough, that's what it did. Now, what I want it to do next is 5-15 to 7-15 to close the loop. Let's see if it does it. 5-15 to 7-15. Holy crap. This is amazing. It's predicting what I want. What I want is not written down anywhere. Maybe there's some crazy structure to this math, which is possible that it's predicting. But I can't believe this is happening. And this happened for all those other designs. I've saved the biggest, most complicated design for last year. So let's keep going. Okay, so now it knows I'm on rectangle number 3. So this is 0, 1, 2, 0, 1, 2, 3. So I want 9, 3, 9, 5, 7, 5, 7, 3. So we're going to do 9, 3. And sure enough, so now it's caught on. Now it's picked up that I actually want to do 9-3 to 9-5. That's amazing. Those first 3 blocks were required for me to give it a pattern. Now, and remember, I got it. When I made the first one, I had to correct the first 2 points. When I made the second one, I had to correct the second 2 points. Same with the third one. Now for this fourth one, it's already figured out, okay, I see what you're doing. You're going clockwise on this diagram. I don't know how it knows what I'm doing. So the next thing here is I want 9-3, 9-5. I want 9-5 to 7-5. And sure enough, it predicted it. Like, you guys are seeing this live in real time for the first time, with me. So I want 7.5 to 7.3. Sure enough, that's what it did. I want 7.3 to 9.3. Sure enough, that's what it did. So now the next one over is 11.5, 11.7, 9.7, 9.5. So I'm hoping that it will predict that we're on block number 4, which is 5. And I'm hoping it'll start with 11.5 and go to 11.7. So let's just see if it can predict that. 11.5 to 11.7, block number 4. I mean, you guys just we're seeing this together in real time for the first time. I'm blown away. Okay, so I'm hoping that it will do, pull this in a little bit. Okay, so I want 11.5 to 11.7, so I want 11.7 to 9.7, and sure enough, that's what it predicted. Go on to the next one, 9.7 to 9.5. Yes, that's exactly what I was thinking. How did you know that? And then 9.5 to 11.5 to close the loop. How did it know that? I don't even know. Let's keep going. So the next loop is going to be 13.7. Sure enough, it knew that I wanted to do 13.7 to 13.9, and that's block number 5. It seems to have caught on now. The next one is 13.9 to 11.9. Sure enough, that's correct. 11.9 to 11.7. Yep. 11.7 to 13.7. Yes, that's what I wanted. So the next block will be 15.9. Sure enough, 15.9. Now I got this one wrong. It did 15.9 to 15.1, but it should have been 11. So I will correct it. Let's see what it does next. We want 15.11 to 13.11. Sure enough, I got that right. 13.11 to 13.9. Sure enough, got it right. 13.9 to 15.9 to close the loop. Yep. And then finally, that's it. So those. Okay. Now we're going to go on to the next conceptual compositing level. And I just wanted to refer back to an example I've done before to show you the effect I'm trying to get, because this can be kind of confusing if you're not clear like what I'm trying to do. So I really love this idea of interleaving, like interwoven, I call them braids. So this idea, like this line here is on top of that other line, but goes under this guy. And then this guy's on top, but goes under this guy, etc. So I love this look and this pattern. That's what I'm going for here. So I've zoomed in on this diagram a bit. So I'm going to call this the interior braid. And the way this works is, and I'm sorry, it's a very busy diagram and I'm using my mouse, so if this is hard to read, I apologize. But there are two 7-sided objects and they're slightly offset. So this guy here goes from 3.1 to 5.1 to 7.1 to 9.1 to 11.1 to 13.1 to 15.1 back to 3.1. So that's one. And it's on top of and rotated slightly of another object. And that object is here. So this is the reciprocal. So this is like 1 over 11 to 1 over 13 to 1 over 15 to 1 over 3 to 1 over 5 to 1 over 7 to 1 over 9. And notice there, again, it's a reciprocal. So this is a 1 over 9, but if you draw a straight line through that point, through the origin, which is the 1, 1, you get the reciprocal, the 9, 1. That's true for every one of these things. So 3, 1 goes to 1, 3, 1, 11 goes to 11, 1, et cetera, et cetera. So that Erv is paid a lot of attention to like hypersymmetry. But so here's the thing: to get that cool braid effect, I have to kind of hop back and forth between drawing these two things. I'm not going to just draw a 7-sided figure and a 7-sided figure. I'm going to draw one line of this first 7-sided figure, then one line from the other, then one line from the first, then one line from the second, and I'm going to hop back and forth so I get that cool braid effect. And we're going to call that the interior braid. So going back over here, we're going to let it predict something. Now, I have no idea what it's going to do here. There's a very complicated pattern. It's not symmetric at all. I don't know what's going to happen. It may fail. So let's just see. So we're going to start with 3.1 to 5.1. So I will correct it, 3.1 to 5.1. And I don't think we need a comment here. Okay. So let's see what it thinks I want to do next. So what I really want to do is instead of 5.1 to 7.1, what I really want to do is I want to draw the first line from that second object. So I want to go from the 1.11 to the 1 over 13. And, you know, there's no way it could know that that's what I wanted to do. So I'll just correct it. Let's get the party started. So we want 1 over 11 with 1 over 13. 1, 13. Okay, so let's just see what happens. The next thing I want is, you know, I did the 3, 1 to the 5, 1, did the 1, 11 to the 1, 13. The next thing is I want the 5, 1 to the 7, 1. So it did not predict that, but no surprise. 5, 1, 7, 1. Now, the next thing I want is I want the 113 to the 115. Now, it got the 113 right. It got the 313 wrong. So we will correct that. Now, the next step is I want from the 7, 1 to the 9, 1. And wow, it got that one right. So let's keep going. Now I want the 115 to the 1 over 3, and it got that right. It's already picking up on this very complicated, very arbitrary pattern, right? So I want the 9, 1 to the 11, 1. It got that right. I want the 1, 3 to the 1, 5. It got that right. 11, 1 to the 13, 1. And it got that right. Then I want the 1, 5 to the 1, 7. It got that right. 13 to the 15. It got that right. The 1, 7 to the 1, 9. It got that right. I want the 15, 1 to the 3, 1. And it got that right. And let's see if it can close the loop. And then the 1, 9 to the 1, 11. And it figured that whole thing out. That's insane. It's absolutely insane. Okay. So the front one, okay, so the back one was this one. The front one is just 1 over. It's like offset over. So we were drawing the back one like this rectangle and then this rectangle, which is like a skip. This guy's like in the middle. So we're gonna do the 15, 11, and we're going to do the 7, 13, etc. So let's just see if it can catch on to what we're doing here. So we'll accept the first one, and then we want 15, 11 to 7, 11. I'm sorry, 5, 11 to 7, 11. Now let's see if it can figure out. We want 7, 11 to 7, 9. So I got 7, 11 right, but it didn't get that one right. So we'll do 7, 9. We want 7, 9 to 5, 9. It figured that one out. 5, 9 to 5, 11. Figured that one out. Sorry, and let's label this 0. Let's see if it can figure this next one out. So remember, we want the 7, 13 at this point. And sure enough, it got 7, 13 right, but it got 9, 13 right. Sorry, my bad. It's right. 9, 13 to 9, 11. Yep. 9, 11 to 7, 11. Yep. 7, 11 to 7, 13. Oh, it didn't get that one right. So, how did that happen? But you got that one right. Okay. Next one. So we're doing this one, this one, and this one. So we're doing 9, 15. And it got that one right. 11, 15 to 11, 13. That is correct. 11, 13 to 9, 13. That's right. 9, 13 to 9, 15. That is correct. Now we're on to this one, the 11, 3. And I got that one very wrong. There is no 17 at all. I don't know where it came up with that. So we'll correct it. 11, 3 to 13, 3. Whoa. And let's see, we want 13, 15. It got that wrong. So we'll correct that. 1315 to 11.5. I'm sorry, 1115, I got that right. And 1115 to 11.3, I got that correct. The next rectangle on our necklace is 13.5. I got 13, and we want 13.5 to 15.5, I got it right. 15.5 to 15.3 is correct. 15.3 to 13.3 is correct. 13.3 to 13.5 is correct. That was 100%. And then the next one over is 15.7. So our next guy is 15.7, and that should be a 3.7. Should be a 3.5. So I got a little stuck there, and I'm wondering if we're running into a context window problem here. And in our last rectangle is here. 3.9 to 5.9 is correct. 5.9 to 5.7 is correct. 5.7 to 3.7 is correct. And then it should be 3.9, and that's it. So it finished our front necklace. Okay, finally, our last logical group is the perimeter. So we're going to start from 3.11, 5.11, and we're going to go around in a circle here. And let's see if it can catch on. So I've started already with 3.11, 5.11. So I've put that in here. So the next thing it should predict is 5.11 to 5.13. So let's see if it could do that. We got the 5.11 right, but the 5.13 wrong, so I'll correct it. So now I want to see 5.13 to 7.13, and it got it. That's amazing. So I want 7.13 to 7.15, yes. 7.15 to 9.15, yes. 9.15 to 9.3. Oh, so I got that one wrong, so we'll correct that. 9.3 to 11.3, yes. 11.3 to 11.5, yep. 11.5 to 13.5, yes. 13.5 to 13.7, yes. 13.7 to 15.7, yes. 15.7 to 15.9, yep. 15.9 to 3.9, yep. 3.9 to 3.11 to close the gap. And it got it right. So, you guys, come on. This is incredible. Like, I cannot believe it was picking up all these patterns. And these are very different patterns, right? Like, we had a necklace pattern. We had that braid in the middle where we had two seven-sided shapes that were rotated, and we were alternating lines between it. It figured that out too. And then we had the perimeter. It figured all these patterns out with just a couple guesses. And again, it has no knowledge of how I want to draw this. All it knows about is the code that exists. And the code is really just declaring all these different points. It's not defining any lines or anything. So I don't know how this is working, but it's working. So anyways, mind blown. I know it's very tedious, but this is a day in the life of a programmer. This is what I do. This is how you make art with code. So yeah, very, very tedious and much, much harder without tools like this. So hats off to Cursor and OpenAI ChatGPT. Right.